Hey, it must be 2 hours UTC because it's Astronomy Daily Live. And here is Cosmic. And everywhere else is Cosmic too. So, hey, everybody, glad you could join in for yet another daily live stream talking about astronomy for an hour-ish or so, something like that. Hope everybody's doing well. Been yeah, been a pretty normal day around here. Relatively speaking, it's been a little bit cold. I heard some areas around me got a little bit of snow. Boo hoo hoo. You know, Arizona snow is lasts uh, 5 minutes sometimes. So it's pretty exciting when there's some snow, but it's nice when it goes away. All right, let me check my streaming here. That seems to be going. I'm going to pop the chat out, which I haven't done yet. In fact, it's probably running, so I want to get off of that and pop the chat out. So, hey, everybody, glad you could come by. Those of you who are live, hey. And those of you in the future, hey. Hope everybody's doing well. If you're new here and like what you're hearing and maybe even seeing, make sure to subscribe. You can set the notifications so you don't even have to think about when I go live. But yeah, one of the fundamentals of astronomy is having a grasp of time and how time is measured. So I start this at 2 hours UTC, and I leave it up to you to figure out what that time is for your locality. Now, where I am, I'm in southeastern Arizona, where it's dark and quiet, and southeastern Arizona is always on Mountain Standard Time in the United States, which is 7 hours behind UTC. So 2 hours UTC on the 21st of February, which is the date of today's live stream, for me is actually 7 p.m. on the evening of the 20th of February. But that's just one of the couple of things that you just have to wrap your mind around. And hey, Susan, nice to see you in the chat. Hope you had a good day. Mine, mine was well. Made some little bit of progress on one of the modules. Still needs a little bit of work, but yeah, I think hopefully by tomorrow uh, I'll be able to move on to the big one, to the output stage, and then put it all together and see if we can continue to flip some protons. So yeah, hope you had a good day. As I said, mine was good. So yeah, you can set your notifications to tell you when I go live, or you can figure that out yourself. Um, So this is just a casual get together of friends, and we talk astronomy for about an hour or so. I like to keep it open-minded but skeptical. So when there are some new ideas or even some old ideas, uh, it's fun to rip those apart and look under the hood and sort of see how they're working, question everything, That's good science. Not in a mean way, of course not, but in a very skeptical way that's also very open-minded. So I like to keep both of those things. It's a good balance, I think. So tonight's uh, I have two drinks of choice. Okay, one is just the regular old coffee. Now, I think I got distracted when I was talking about the coffee a couple of days ago. This is um, this is a Kona blend, and Kona blend is you know when you've been to the mountaintop, nothing is quite as good. And so I've had 100% uh, Kona coffee on Maui. There's a great coffee place called Badass Coffee, and every time I um, traveled to Maui, which was at least a few times a year for a few years or so, it was just horrible the whole time. Flying out to Paradise and having uh, being set up on a condo on the beach. It was pretty rough. It was pretty rough. But what got me through it? Okay, there's two things, right? Well, there's three things that got me through that. Okay, number one was the work. The work was really awesome stuff, fun, challenging. Um, yeah, that was great. The second thing that got me through that was Jamba Juice. Okay, Jamba Juice. That's where I discovered Jamba Juice and realized soon afterwards that it wasn't such a specialty for Maui, but at the time it was like it was great. So I sort of lived off of that. And the third thing, for sure, for sure, was 100% Kona coffee from Badass Coffee Company. They're awesome, and once you've once you've uh, drank Kona coffee, everything else is just sort of in the just sort of way down. So this is the typical 10% blend, which is adequate, right? It's got a nice chocolatey flavor, uh, but it's not even it pales to actual 100% coffee. So anyway, cheers. This is one of those really thick mugs that sometimes you find in restaurants and things. I've dropped this a few times from a reasonable height and hasn't broken yet. So it's a nice heavy mug. So cheers. Hmm. And tonight's other chemical concoction is yeah is the hydrogen hydroxide. It's still a relatively fresh batch and always quite awesome. So cheers to that too. Yeah, um, I haven't been in a McDonald's in decades. so, so yeah, yeah, not bad, huh? Okay. All size cups are $1. That's pretty good. That's that's uh, that's all right. So yeah, hope everybody's doing good. As I said, this is just a casual get together of friends to talk astronomy for a little while. Uh, and if anybody in the chat or um, in over on my Discord server has any comments or questions or topics or anything to chat about, I am all ears. If not, I always right back here. I've got uh, practically an infinite number of topics to chat about. Never, um, yeah, the science of astronomy is so broad that it just encompasses everything. I saw a pretty good lecture talk by Neil deGrasse Tyson. I think it was, yeah, it had to have been relatively recently because he showed the Falcon Heavy launch. By the way, before I get into that, I have to mention, and maybe I'll just show it here. Maybe I'll share my screen. See, I'm going off on these wacky tangents, but that's one of the great things about a live stream is that this can go all over the place. I'm you know I'm I take my cues from sort of two current live streams. The first one is uh, is Gilles, and Gilles is up in Montreal, and he's a shortwave enthusiast, and he's passionate. He's passionate about shortwave and radio and computers and all that. And he does a live stream at least once a week, either Fridays or Saturdays. And I think his YouTube channel is called Official SW. Let me get it here. Let's see if I can find it this way. Official. Official. See, I'm just going off on all kinds of tangents here, but that's okay. Official. Maybe that's not it. Anyway, he's a good inspiration. The other one that I really like is Rick Beato, and his live streams. He's doing one practically every night as well. Now, what was I going to do over here? Oh yeah. Um, there's a launch. There's a rocket launch of a Falcon 9 from Vandenberg Air Force Base. That's over in California. Tomorrow evening. Tomorrow evening is when it's planned. There's this really great website called Launch Library, library.net. Oh, .net. Launchlibrary.net. And these are sort of run by the folks um, who I don't think it's exactly run by the folks who are doing the tomorrow um, broadcast every Saturday, but they sort of um, started this, and the community around them um, gathered together and um, developed this. So, if you want to know anything about what is going to be happening in terms of launches worldwide, go to launchlibrary.net. And as you can see, they list all the upcoming launches. And here's the Falcon 9, February 21st, 2018 at 1417 UTC. So for me, I have to subtract 7 hours from that. So that's at 7:17 a.m. my local time. Now, as I said, I'm over in southeastern Arizona. This launch is happening in Vandenberg. Now, the last Falcon 9 launch, which you probably heard about, because it was a night launch and it went right over Disneyland, and it freaked a bunch of people out, of course, and it was quite spectacular, was visible from my location, but I don't know how I didn't know, but I completely just wasn't paying any attention to that one at all, so I didn't see it. This one is happening about 17 minutes or so after sunrise. So I'm gonna try. I'm gonna try to go out and see it. I'm sort of, I'm gonna be looking west, maybe southwest or so, really low. I've got a mountain range to my west and southwest, so I don't know if I'm gonna see it or not. But these rockets go up into orbit. So the possibility of seeing it is pretty slim, but I will definitely give it a chance for sure. But yeah, so check out launchlibrary.net if you're interested in sort of following uh, launches from everywhere. So here's one that is launching on the 25th from Japan. Then there's another Falcon 9 on the 25th as well. Then there's a Soyuz launch uh, over in I think they launched from Kazakhstan, if I remember right. I think that's where that's going. That's on the 1st of March. Then there's an Atlas 5 that's going off in Florida on the 1st as well. It just goes on and on and on, right? So these guys, or these people, I should say, um, they keep close track of all the launches, right? So they've got launches all the way. Well, see, they don't have any dates on these. Let's see when the last date is. Last date is all Falcon 9. So they're going sort of into April or so, something like that. But you can see, there's a lot of launches going on, lots and lots of launches. I see suborbital launches from they're coming. I think they're coming out of White Sands. It sort of looks like contrails over to my east, but and I think maybe a lot of those are either contrails or chemtrails. Um, but some of them look a little strange, and so those are probably the suborbital flights. So they can shoot a rocket. It doesn't have to go into orbit. It just has to get really, really high, and they have some kind of payload on there to do whatever kind of measurement they're doing. Anyway, I digressed onto that. There's a recent um, talk that Neil deGrasse Tyson gave over in Dubai. And as I said, it was relatively recent because he showed the Falcon Heavy launch, the big one that SpaceX just launched. It was a test launch, but pretty successful and pretty epic, I would say. So maybe I'll try to find a link to that and put it in the description uh, after this live stream is done. So I'm going to stop sharing, and I'm going to have to torture you with this again for at least a little while. Cheers. Let me go over into the chat here and see if anything. Do I know the location of the stars in the sky? Can I name the constellations? Um, I definitely cannot name all of the constellations, and I I definitely don't know the locations of all the stars in the sky. But Susan, I've been looking at the sky for uh, 40 probably 43, 44 years or so. So just through sheer repetition, one gets to know the sky really, really, really well. So can't necessarily claim, that I know all of it, or maybe not even half of it by name, but I definitely recognize all the patterns. Now, since you brought that up, uh, I one of the things that I hope to do. I mean, I don't have any direct plans or anything, but if the opportunity arises to travel to the southern hemisphere, it's a completely different sky down there, and for practically the first time in my life, I will be completely lost in the sky. I wouldn't be able to recognize anything at all. All the constellations that are usually to our south here would be in the north, and they would be upside down. So the constellation of like Orion, you know how it is now with Betelgeuse in the upper left and Rigel in the lower right, and the belt going that way. I guess um, doing it on the screen would be that away. Uh, it's completely flipped over if you're in the southern hemisphere. So yeah, I would be completely lost there. I would need a guide of sorts. But but I do have charts. I do have charts. Know how to read charts. Know how to translate between what I'm seeing on the charts and what I'm seeing in the sky. So I could definitely get around just fine. Wouldn't recognize a thing at all. So northern hemisphere, yeah, for sure. Southern hemisphere, no, no. Yeah, and the actually the dippers change position all the time. That really isn't a that really isn't dependent on latitude at all. Now where they are in the sky, yes, but um, the orientation of the dippers, uh, that sort of depends on when you are looking at them, either the time of night or the time of year. So yeah, yeah. All right. I think what I'm gonna do, I sort of thought of a new thing to do that wouldn't be too heavy, but it would also be, you know, it would sort of satisfy my my need to talk astronomy, but also sort of allow me to talk about some of the basics um, as well. So what I thought of doing is like an object of the day, object of the day. So there are lots and lots and lots of things up in the sky to look at. Um, there of course are all the stars. Those aren't just to be looking at stars. It's not so interesting. But anything that is not a star, so-called non-stellar objects like galaxies or clusters of stars or nebulae or planets, even binary stars, are a little bit more interesting than just um, single stars. What I thought I would do is do an object of the day, and I've got a huge choice of objects. So what I decided to do just to start, there's a catalog of of um, non-stellar objects. Hello, Bobby Shane. What's new in the astronomy world? Hey, it it's almost it's almost new all the time, and that's why doing a live stream is kind of neat because we can sort of keep track of all the new stuff as well. But yeah, I'm trying a new thing tonight, calling it object of the day. Now, there's a catalog of non-stellar objects, and it's called the New General Catalog, NGC. And I believe there are something like 7,840 NGC objects. So these can be galaxies, they can be open clusters, they can be globular clusters, they can be planetary nebulae, they can be diffuse nebulae. Um, I think that's about it. But there are like 7,840 of these in this one catalog. And there's lots of catalogs, lots of um, different ones. And we'll actually get into that a little bit as I move through this. So what I'm going to do is I'm going to go to a site called random.org. And random.org is really, really cool. It will choose a random number for you. And I have to study this a little bit more, to understand exactly how they generate they're random numbers, but they say here that the randomness comes from atmospheric noise. So, well, I don't know what that exactly means, but yeah, as we do this more, I'll find out. But over here, oh, I'm not. I've got to share my screen first. That's awful. Okay, we share the screen because otherwise you're just gonna have to stare at this ugly face, and that can only take so much, right? Okay, so now we're on random.org like that, and you can see here. I'll read that again. The randomness comes from atmospheric noise, so that's kind of cool. So over here, you can choose a minimum number and a maximum number. So there are 7,840 NGC objects. Okay. And so what I thought I would do, and I may not do this every single day, but maybe I will. I don't know. Let's see how it goes uh, today. And yeah, I was sort of playing with this this morning, and it was kind of fun. So I'm just going to generate a random number between 1 and 7,840, and that will be the NGC object that we'll go and look at. So I'm going to generate that number 2446. So what we want to do is we want to look for NGC 2446. And what I'm going to do is I'm I'm actually aiming for a particular site, but I found that sort of the easiest way to get to a particular object, NGC, what did I say? 2446? Oh, I forget already. Let's go back. Yeah, 2446. So NGC 2446. Let's see what this is. I have no idea what it is. Could be anything. It is a spiral galaxy. Okay, so what I want to do is I want to actually go to a particular site. It's called Simbad. Simbad. And Simbad is an astronomical database of everything that you can possibly think of in terms of astronomical objects. Whoop, that's the wrong one. 6177. How'd that happen? Did I do that? Oh, I did. That was kind of dumb. 2446. Why did it do that? Let's see if we can. Well, let's just do it this way then. Let's just do it the hard way. We'll go over to Simbad, and I'll go to the main page, and let's just type in NGC 2446. See what we get. It's taking its time. Taking its time. Looks like it's a galaxy. The galaxy in a group of galaxies. So galaxies come in different shapes and sizes, and there are many different kinds. I am definitely not going to go through them all because that's just, there's a lot of them. There are basically three primary types of galaxies. Okay, there are spiral galaxies, which, as the name implies, they sort of have a spiral shape. Uh, there are elliptical galaxies, which just look like sort of off round blobs, and then there are irregular galaxies. And irregular galaxies just they as the name implies, they're two. They're not spirals. They're not ellipticals. They're just kind of weird shaped. This particular galaxy, NGC 2446, is an SB galaxy, which means it's a spiral. That's what the S stands for. The B corresponds to sort of how tight or loose um, the spirals are, and these are like spiral arms. Okay, the Milky Way is thought to be a spiral galaxy. But I don't know if it's an SB or an SA or SC. I I want to say an SB, but I'm not quite sure. But this particular galaxy, NGC 2446, they claim is an SB galaxy. Over here, you can see how bright it is. These are visual magnitudes um, at different wavelengths. So this is blue, this is red, this is a little bit more red, and this is even more red. So you can see, you know, the magnitude scale, the brightness scale um, um, in astronomy is sort of backwards. So the larger the number, the fainter the object is. So, but if you look at the object in different colors, they can get either brighter or dimmer. And in this case, you can see that as you move towards the red, this galaxy actually gets a little brighter. So, you know, maybe we would call that a red galaxy because it's bright in the red. So let's see. Let's just go down here. We've got some images. I don't know why my arrow keys aren't working. Let's see. A lot of whoops, a lot of catalogs, tabular data. Wonder if I can just do that. This is the entry I was actually looking for. So this is a galaxy in a group of galaxies. I would call that a cluster of galaxies. But they like to call it a group. And the first thing that you see here are the coordinates. So this is where it is in the sky. So these first three numbers uh, um, show what's called the right um, um, the right ascension. So it's sort of analogous to um, longitude on Earth. So this is sort of the east west position, and right ascension goes from 0 hours all the way around to 24 hours. So you know they've divided the entire sphere up into 24 chunks, uh, and so within each hour are 60 minutes, and within each minute is 60 seconds. So this is actually sort of a measurement of, in a sort of a strange way, um, uh, this is sort of a measurement of time as well. But it's just a coordinate. It's just a left-right um, coordinate. It's like a longitude um, up in the sky. And then these next three numbers are what's called declination, and that is sort of like your latitude. So yeah, so that's what that is all about. And there are different coordinates depending on uh, various things. Again, you're seeing the magnitudes here. There's the type again, it's an SB. This is how large it is in arc minutes. So one arc minute is 1/60th of of 1 degree. Just to give you a sense of scale, the full moon is about 1/2 of a degree wide, so about 30 arc minutes wide. So this galaxy is at 2 arc minutes. It's actually 2 arc minutes by 0.77 arc minutes. And if you look over at the picture here, you can see 2 arc minutes would be along this long axis here, and 0.773 would be along this axis. Like that. I'm not quite sure what that 125 is. That might be the position angle. So it's this angle. If this way is north, right? If this way is north, then this angle here across north is 125 degrees. Now, what you're also seeing here is these blobs here, these things. Most likely, these are foreground stars. So these are stars in our galaxy. So we're looking through that at this galaxy that is far, far away, and we'll probably get some info, some measurements on exactly how far. This basic information is not saying that, but we can scroll down here. There's a whole bunch of information here. That's why I sort of like this to present this, because it sort of gives um, anybody new to astronomy sort of a sense of what kind of information you can extract from this kind of data. It also gives a well, no, I'm not going to get into that. Let's see. So here's a table of all the other names that this object goes by. See, so this is the NGC catalog, but there's also a catalog called IRIS, a catalog called ISOSS, KUG, LIDA, blah, 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 just on and on and on, right? Just all of these. So this is all the same object, just known as different names. Let's see what else we got here. Oh, so cool. Yeah. So we get into references. Why can't we, why aren't we seeing the references there? Try to display them. So these are references to professional papers that in some way, somehow, mention NGC 2446. And as you can see, between 1998 and 2018, there were 23 references to this object. So a lot of these are just surveys or catalogs, and yeah, that's sort of what I'm seeing here. Some spectra. This is a catalog. These are some radio telescopes, looking at it in the radio light, measuring redshifts, galactic distance database, all digital H1 profile catalog. So all of these papers mention NGC 2446. So if for some reason you have an interest in this galaxy and are wanting to study it, one of the first things that you would do as a professional or as a student or just as a researcher in general is you dive into the literature and see what we already know about this beast. And I can say this is a pretty nice looking galaxy, pretty nice. So this is an SB. I was saying that the B uh, sort of represents how compact these spiral arms are. And as you can see, or maybe it isn't as obvious, but I'm going to tell you, yeah, that's sort of medium compactness. It's not really, really tight, not really, really loose. An SA would be really, really loose, and an SC and there may be other ones too. SD, I'm not sure. Would get more and more tight. So let's look at another image here. Let's see if that pops up. Okay, so this is from another catalog. Yeah, not too interesting. Let's look at this one over here. Sloan Sloan Digital Sky Survey. Not seeing anything there. Let's go over to Iris. Not seeing much there either. Look at Galax. Not seeing much there either. So the Digital Sky Survey looks like the best one. That's what the DSS stands for, is the Digital Sky Survey, the digitized sky survey, perhaps. Uh, anyway, that's a pretty galaxy, pretty nice, and it's at least in the visible, it's magnitude 13.9. So the telescope that you see behind me, if I was just looking with my own eyes through that scope, nope, I would not see that galaxy. That's too faint. Too faint to see, but I could take a picture of it for sure. You know, do a long exposure, and I would definitely be able to pick that up. So yeah, here's just all the papers that refer to this particular galaxy and probably lots and lots of others. Let's see what these measurements are. Okay, so they have a distance measurement, at least one. So let's see what that is. So they have a measured distance to this galaxy to be 80.42 megaparsecs, MPC. A megaparsec is a million parsecs. And a parsec has a formal definition, but for right now, I'm just going to throw out the number to you. Let's see. We're going to get it. It's something like 3.26 light years, if I remember right, but I don't know the number exactly. So let's just find out. Parsec. Parsec is, well, let's see. Parsec. Uh, parsec. Yeah, 3.26156 light years. So a light year is just the distance that it takes light to travel in 1 year. And light travels at about 186,000 miles per second. That's about 300,000 kilometers per second. So that's really, really fast. Um, Light travels from the moon to the Earth in a little over 1 second. It takes light a little over 8 minutes to go from the sun to the Earth. And to the nearest star that isn't our sun, that's about 4.3 light years away. So there is no star um, within a parsec of us. But this galaxy, okay, this galaxy is 80.42 million parsecs. So I'm going to reach over onto my desk. Every good scientist has a calculator at arm's reach. So I'm going to take 80.42, 80.42 million. So that's 10 to the sixth. Okay. So that's that many parsecs, 80.42 million parsecs. And I'm going to multiply that by 3.26 light years per parsec to get how many light years it is. And that is 262,169,000 light years away. So the light that we are seeing from that galaxy, if I were to go out tonight and look at it or photograph it through my scope, right? The light that I'm seeing from it tonight started from that galaxy 262 million years ago. So that's quite a long time ago. It's taken a long time to get here. And when I look at these objects, I definitely have an appreciation for that kind of effort. That light went all the way from that galaxy, has traveled 262 for 262 million years to go into my eye. That's awesome. That's very, very awesome. So that's pretty far away. Pretty far. Quarter of a billion light years. Yeah, not bad. Not bad. The other thing that they can measure is is whether it is moving towards us or moving away from us, and they can measure how fast that is as well. And that's what this RVEL is. Well, there's also a velocity thing here too, um, but that's saying that it is moving away from us. That's why it's a positive there. It's moving away from us. The distance is getting larger and larger and larger. So it's moving away from us at roughly 5,600 kilometers per second. I'm pretty sure that's what the units are there. So yeah, 5,600 kilometers per second, it is moving away from us, or we're moving away from it, right? I mean, all motion is relative. So, we aren't stationary at all. So yeah, we're um, we and this galaxy are moving apart from each other at about that speed, 5,600, and depending on how you measure it and how good your instrumentation is, uh, how precisely you can make the measurements. You get a little bit of a spread here. See, so 56, 71, 68, 72, 68, 68. So, they aren't all going to agree, but, they're relatively close. So that's a pretty precise number. So let's see, is there any other interesting things in here? Just a regular old boring galaxy. Nothing much to it. So what we can also do is we can go, I'm going to go back down here. Sorry, I'm probably making you dizzy. We can go to NED. Okay. NED is another database like Simbad, but it's got more stuff. And NED stands for the NASA IPAC Extragalactic Database. Okay, so this is all about NGC 2446, is the object of the day randomly chosen by our random number generator. Again, it shows the right ascension, RA, and um, the declination. Object type is a G, it's a galaxy. And you can see there's the velocity again. Here's how bright it is. Some references, blah, 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 blah. Here's maybe some pretty pictures. Let's see. They're all fits images. I don't know what that is. Let's see if can we grab that one? I don't know. Let's find out. So there's another image taken from a survey of some sort. And, you know, if you're into numbers, uh, definitely get into astronomy because there's a shitload of numbers when it comes to astronomy. Okay, there's even more down here. That's cool. So just different. These are, of course, the same galaxy, just taken um, with different filters. So we're looking at different wavelengths here that are represented by these letters J, H, and K, KS in this case. And it's all that they've done is they've taken these three images and they've sort of said, okay, let's make J red and let's make H green and let's make K blue. And then they've combined them. They've just added them up just adding them up, and you come up with sort of a colorish type of a image. All right, well, that's pretty cool. Let's see if we can. I don't think we can see these fits images. No, no, it's gonna complain about that. Yeah, yeah. Well, I'll talk about um, fits images at some point. FITS, that stands for Flexible Image Transport System. And it's just a file format. So it's, you know, um, JPEGs or AVIs or MP3s or anything else. That's just a file specification. It's just a way, to package data. And fits is one of those. It's sort of the astronomical standard. Um, as the name implies, it's very flexible in terms of what kind of information you can store in these files. It's very, very awesome. Very awesome. We'll talk about that at some point. I don't want to do too much with that. So let's see. So sort of the same kind of information as with Simbad. These are just all the other names for exactly the same object, right? And these guys down here, look, are calling these irregular spiral. They're calling it an irregular spiral. Wonder what that's all about. Here's just sort of a different way, to represent positions in the sky. They're actually doing it by what they're calling longitude and latitude. And there's a way to go from longitude to right ascension, and a way to go from latitude to um, declination. You can sort of see that the latitude here starts with a 54, and so does the deck. So maybe that's a giveaway for you. Anything else interesting here? See, they don't have a position angles here or anything. Position data points. See, what's this? Distances. Okay, so they've measured the distance here as well, and they're getting something different. See, they're getting 72.556. So, they're measuring it in sort of a different way, and they're getting a different number. So, you know, uncertainty. There's a lot of uncertainty when it comes to astronomy. Um, you got to take a lot of these things with sort of a grain of salt because, yeah, eh, you know, these numbers look very, very precise, right, out to 3 decimal places. But um, you know, in the Simbad database, I was measuring like 80, right? So there's a big difference there. Oh, let's see. Galaxy morphology again. It's an SB galaxy spiral. Foreground galactic extinction. I won't get into that. Basic data. Let's see. Okay, so they're getting into radial velocities again. Five. Now this seems to be a pretty good number, right? I've seen 5668 a few times now, so it looks like maybe we've got that nailed down pretty well. But here, yeah, 1.9 arc minutes by 1 arc minute. I think over in Simbad it was saying what 2 point something by 0.773. So there's pretty good agreement there. There is the magnitude again, the brightness of it. Looks like probably a visual magnitude somewhere in the B or somewhere, where the human eye can see it. Here's some more measurements of velocity. And the cool thing is, see, these are all papers. These are references. So this paper, right? Uh, well, they got this number from this paper. And if you want to go and look and see, you know, more detail in terms of how how they measured that number, you can go to the paper and read it. It's awesome. I'm going to have to remind myself what Hubble flow distance is. I don't remember what that is. Scale at Hubble flow distance. Yeah, I don't remember what that is. Here's some more uh, measurements of distance using different methods to do that. Optometry, that's just how bright it is. So here's an interesting thing. This is called absolute magnitude as opposed to the apparent magnitude. The apparent magnitude is just how bright it looks um, um, when we look at it as is. But absolute magnitude, absolute magnitude, absolute magnitude is it's how bright that object would look if it was exactly 10 parsecs away. So remember, um, 1 parsec is 3.26 light years. So 10 parsecs away would be 32.6 light years away. So this galaxy, as you recall, is like 80 million parsecs away. So that's like really, really far, right? But if it was only 10 parsecs away, then it would be magnitude negative 21.15. Now, our sun is about negative 26. So this galaxy, if it were 10 parsecs away from us, hey there, Andrew. Nice to see you coming in. Glad you could stop by. It's getting sort of towards the end here. I'm just doing a object of the day. I sort of just randomly choose an object, and we look at sort of all the information about it in different catalogs. I may be doing this every day, maybe not. That's one of the nice things about having a daily thing is that, yeah, some days I'll do it and some days I won't. But glad you could join in the circle. Uh, yeah, welcome, welcome, welcome. So the only problem with uh, the absolute magnitude of a galaxy is that galaxies are really, really, really big, right? They're much bigger than 10 um, parsecs in size. So to have a galaxy 10 parsecs away and being able to measure its brightness, that's a little strange. So it certainly wouldn't look that bright because we would at a distance of 10 parsecs we would be like inside of that galaxy. So it really wouldn't look much different, than um, what it does uh, um, looking out in the galaxy that we are currently in. So yeah, that's it's kind of a confusing thing. But if you take the combined light of the galaxy as we see it now, and sort of compact it, right, and then place that at 10 parsecs away, it would be almost as bright as the sun. So that's pretty cool. Pretty cool. If you haven't subscribed to this live stream, I encourage you to do so. You can set the notifications so you can be told, when exactly this live stream does go live. It does go live every single day at 2 hours UTC. And yeah, this is just I went to a site called random.org and I said, okay, there are 7,840 NGC objects. So let's choose a random number between 1 and 7,840. And it came back with 2446. So we're looking at the object called NGC 2446, which turns out to be a pretty nice looking spiral galaxy. I think it says what constellation and maybe it doesn't here, but I thought it did somewhere else. Uh, yeah, it doesn't say. It says here. Let's go back to Simbad and see. Did it say it here? I don't remember either. Remember where we saw that? Where did we see that? I don't know. Let me go back and back and back. CDS portal. And find out where, at least what constellation it's in. I'd be able to figure it out from the coordinates if I thought about it for a couple of seconds, but I'm being a little lazy. Just a little lazy. I thought 446. I don't know why we're getting all these other weird ones. Oh well, it's out there somewhere. Yeah, that's 6117. That's the wrong one. I remember. Oh, that's right. We went forward one more to get to here. That's what I did. Okay, well, cool. I sort of like this object of the day thing. Maybe I'll stick to that for a little while. But it's a nice looking galaxy. It's uh, it's not exactly face on because it does have a shape. It's got a long axis here and a short axis. And you can see in this image that there are some galaxies, uh, at least in the same field of view. This did say that it was part of a cluster. So these galaxies might be part of that cluster too. See, here's sort of an extended one here, and here's a little fuzzy thing up here, much fainter, much smaller than that one, of course. But yeah, it's a pretty galaxy, pretty. Let's see if we can zoom out even more. Maybe we can see more of these guys. Doesn't. Oh yeah, it's trying to fill in. There it goes. That's like a strip. Oh, here's a cool looking galaxy. This is like an edge-on galaxy here. Let's just zoom in on that. So almost everything that you're seeing in this field of view are foreground stars. These are stars in our galaxy. This is a star, big bright star. The reason why you see these funny things coming off like this, these are called diffraction spikes. It's a optical effect caused by the telescope, and that's what causes these circles and rings around things too. It's the optics of um, um, the telescope. But so this is 2446 up here, but I just saw this really cool looking edge-on galaxy here. So let's just zoom in on that, just for fun. I have no idea what galaxy this is. Oh, wow, that's a real zoom. Oh, that's pretty cool looking. See, so that most likely is also a spiral galaxy, but we're seeing it edge on. So spiral galaxies are a lot like plates. So they are like a disc, and so they're very flat. And as you can see, that's pretty flat. It's got a bulge in the middle, right? But as I said, everything else in here, except for maybe a couple of these little smudgy things, are foreground stars in our galaxy. But yeah, let's zoom out a little bit again. Once I get into these, I get pretty excited about seeing what else is out there. So here's 2446 up here. This is the guy that we were looking at. This is the edge on that we were just looking at now. I'm not really seeing much of anything else here. Let's just sort of zoom around. Isn't this cool that you can do this from the comfort of your own home? You can have access to this kind of information from the comfort of your own home. So yeah, I'm just seeing lots and lots of stars. Lots of stars. All of these are in our galaxy. There's a big bright star, it looks like. Here's another galaxy up here. No idea which one it is. Let's zoom in on it. See, so these days, you don't even need a telescope anymore. You don't even need a telescope. You can access these guys and see some nice stuff. Ooh, look at that one. Ooh, I don't know what that is. That might be like a planetary nebula. Doesn't look like a galaxy. This definitely is a galaxy of some sort. But I don't know if you can see it in up here in the upper left. It gives you the right ascension and the declination of your mouse. So you can sort of move around and see how that goes. You can see that this is north. That number start at the bottom here. Okay, if you look at the declination, these last three numbers, you can see if I start at the bottom, so 5654, and if I move to the top, it goes to 5704. So um, um, declination is getting higher as you move north and lower as you get south. It goes to 0 and then it goes negative. And right ascension is the same kind of thing, right? We're going from 744.38 to 743.10. So right ascension increases to the east. So this is west over here, and this is east over here. So north, south, east, west, just like that. And so this is sort of the orientation in the sky. And that's a pretty nice looking little galaxy. I'm kind of curious about this other thing over here. I don't know what that is. Wow, look at all these. Look at this cluster of galaxies there. Wow, look at all those guys. I'll zoom in a little bit. Whoop. Look at them all. Lots of these are galaxies. Some of these might be stars, but definitely that is not a star. See, that's why it's called a non-stellar object, because it's not a star. It's a galaxy. So is that. Oh, I don't know why it zoomed out like that. But yeah, I'm seeing galaxy here, maybe here, maybe here. This looks like a little cluster, but that's kind of cool looking. I don't know. That might be a galaxy of some sort. It almost looks like a ring galaxy. Very cool. Here's another edge on there. These are edge on, it looks like. So this would be sort of a face-on galaxy. So it's still flat, but it's facing us, right? If we were to look at it along its edge, it would look a lot like these, just sort of long things. But we're seeing it almost exactly face on, so it looks round. That's kind of cool looking. Ooh. All right. Well, I think I am going to stop sharing my screen and definitely respect all of your time. Glad you came in. But yeah, I think having a daily live show, anything more than an hour, I think I'm sort of taking up a lot of your time, and there's much to do, So I greatly appreciate all of you coming in. Definitely subscribe if you haven't already. Set your notifications. Hit the thumbs up or the thumbs down. I'm more interested in a reaction than anything else. So if you like this, definitely give a thumbs up. Um, definitely share this um, with folks that you might think would like this as well. As I said, I'm here every single day at 2 hours UTC, and we're talking astronomy for at least a good hour. Try to stay on topic. Sometimes we go off on tangents. If you've got any kinds of comments or questions, or want to have a discussion, um, if you're new or a pro, you are welcome here. Everyone is. This is like a circle of friends, and we're getting together each day. We're turning off the TV, getting away from the news, and um, focusing on a passion of ours, and sharing it with friends. And that's sort of my primary motivation. I sit here every night and I think astronomy. And so it's like, well, hey, why don't I get on for an hour, which is super, super easy. And, instead of, thinking in my head, I'll just sort of think out loud for an hour and yeah, share the passion for sure. It's an awesome science to be in because it covers everything, right? It covers everything from the subatomic to the cosmological to the whole thing and everything in between. And not only um, visible light, that these eyes can see, but we can look at the sky in X-ray or gamma ray or infrared or radio or ultraviolet or submillimeter or microwave, any of those. There is light everywhere, and we just have to go look. We just have to go look. And if we can't see it, we can build instrumentation that allows us to see it. It sort of does the detection and the translation for us, and it's absolutely awesome, absolutely awesome. All right, I'm going to get out of here for tonight. Glad you could stop by. I will definitely see you again in less than 23 hours from now. One more swig from this chemical called hydrogen hydroxide. Cheers. All right. I will see you tomorrow. Same time, same place, 2 hours UTC. Make sure to subscribe if you haven't already. Share this, share it around. I want this channel to grow. I want to have a nice big crowd in here. Um, it's it can just get better with a larger crowd. I'd like to have a couple hundred people in here. I think that would be totally awesome. And then I wouldn't necessarily have to choose topics or anything. I'm happy to do that, but uh, I think you all have much to say and much to ask, and um, much to talk about as well. I'm just the host. This is a circle, so there is no one in charge. I'm no one in the lead at all. It's a circle of friends, and we talk astronomy for at least an hour and 14 today. So, all right, I am definitely going to get out of here this time. Peace, cheers, have a great night, have a great day, and I will see you tomorrow.